Okay, today we'll be talking about the Great Revegetation from 2019 February Silver Contest 4 years ago. So, here Farmer John has N pastures, and he wants to replant these pastures with two different types of grass. However, there are M cows. Each cow has one of two diets, where the cow has to eat the same grass, or the cow has to eat different grass. And each cow has different two favorite pastures. And so what we're trying to find out is how many different ways he can plant the grass in his end pastures just to fit all the conditions of each of his cows. So first of all, they want us to print this out in binary. And this is important because this tells us it's not a problem where you just don't say plus plus, you just add one where you find all permutations. Instead, there's actually a neat trick. So if you think about it, if solution A works like this, so let's say this is a solution where you have this is what cow 1 wants, and this is what cow A wants this, cow B wants this, right? And these are two different pastures. The solution would actually just be how many different components are there. So think about this, okay? In this, there are this is one configuration, two configurations, two different possibilities. Wait, let's just do this. This is two possibilities. Three possibilities. Four possibilities. And our solution would be one. Oh, wait, let's get the brush one. Would be 4, which is just 1, 0, 0 in binary. And this can be shown that no matter how long each of these are, let's say this, you add another one. Let's say you add another one. That no matter how long any of these components are, the number of each of these individual components is the number of zeros that follows this 1. So what we need to do is, so what we're actually trying to find is, first of all, is it possible to fulfill all the cows' preferences? And second of all, if it does fit, we just need to count how many separate components are there. So like, how many different connected parts are there in this graph? So if we had opted to connect, let's say, these two, there would be one entire connected component. However, if you remove a connection, let's say right here, there will be 2 components. This will be 3 components. So we need to count how many different, let's just call them groups that are connected, and add that many zeros after that one if it is possible to fulfill all the cows' preferences. Okay, so this is the solution from the official Usico.guide website, because I wasn't actually able to solve this by myself, so we're going to ignore that in the background. And here we have N and M, with N representing pastures, M representing our cows, and then we're going to create an adjacency list. These two are adjacency lists. And type, this is just to color each node. Like, so this is going to indicate which node has which type of grass. Then we're going to initialize the adjacency list, and this tells us how many connected components are there, like how many of these groups there are. So in this case, there will be 3. Then we're going to go plug in all the edges and fill our connections. If they have the same type of grass, we're going to fill it up. We're going to put it in the same adjacency list. If they have different types of grass, we're going to put it in a different adjacency list. Then, for each node that is not visited, so we're going to start off with node 1 and see, and we're going to visit every single node that's connected to it. So let's say, and this is our visit function. And what it does is we're going to set the type of node to a certain color, and then we're going to check for each of the same nodes, each node in the same. So if the type is not equal to the color, so when it does this, it's doing 3 minus color, meaning that you think about it, if they're different, the two colors add up to 3 since you have grass type 1, grass type 2. So this is going to this determines that if the two nodes that are connected to each other are different, that means it's impossible, meaning that this shouldn't exist and it's not plausible. And we say impossible to true. Otherwise, we can just visit the next node for each of these same nodes. And this is just doing a depth first search for every single connection here. So we are depth first searching. Let's say if this was node 1, we'll be looking for every node that is connected to node 1 and seeing they're all the same. Okay, so like they should all be the same. So we're trying to see if all of these nodes are connected to it are the same. We'll just do that. Yeah. Otherwise, it's impossible, and we have to say that the answer will be 0. Then, likewise, we look for all the nodes that are different from the current node. See if it shares a color with any of its adjacent nodes. If it does share a color, then it's impossible. Otherwise, we're going to set visit and we'll set our color to 3 minus color because we want to change the color that we want to be searching through. Okay, let's just re-elaborate this. So, in this example, if these are all the same, what's going to happen is we are going to be searching through each connection from node 1. So if we all the ones, and this is the same ones, okay? These are same, okay? We imagine it as like two different graphs, one that shows as different graphs and one that shows the ones that all the colors are the same. So in this situation, we're depth first searching to see if all these connections in this node are the same. And then let's say this is 1 again, this one's 1 again, and we want to make sure that they're different. We're gonna be going through. Okay, need to go make sure that this. We'll be going through every single one of these connections and seeing they're all alternating. So like in this case, we go from here to this node, and what that 3 minus color does is alternate that color, because like we said earlier, 3 minus color indicates the color that it should be, or like the different color, like the opposite color, okay? So then using this visit, we can find every single individual connection, run through it and see if each connection is possible. Then if it's impossible, we're going to print out 0. Otherwise, we're going to print out 1 followed by the number of zeros equal to the number of components. And yeah, there's your solution.